Alright, let's see how this goes. Okay, so I'm going to do this just to practice my explaining skills and to make sure that I also understand this problem. So it's construct a binary search tree from preorder traversal. So first thing is, okay, I kind of already started the code here, but let's, so what I'm going to do is go over the strategy and what the algorithm is, and then I'm going to write out the code. So the strategy is basically, what I'm going to do is recursion, where I'm going to go through, so this list here, the input, this input here is already in the order, preorder traversal. So because it's in preorder traversal, that means that we'll see like 8, 5, 1, 7, right? So, but let's break this down into subtrees. So if I break down into subtrees, I'm going to try drawing on a subtree. So 8, that's really bad. This is actually really bad. And 8 will go to, has to be something smaller on the left, has to be something larger on the right. So 10. So the basic code is going to rely on how to treat each subtree. So if you set your root equal to this, then what you want to do is figure out how many values are going to be on the left side. So so what's on the left, and then what's going to be on the right. So how do you do this? Let me write down a little bit more. So you also have 1 and you also have 7 here. So if my root is 8 and I'm going to look to the left, I'm going to want to count how many there are on the left. So my preorder traversal, if you use the spike technique, I know it's like this. It means that you're going to traverse it, like this, pick them up in that order. So I should have 8, 5, 1, 7, and then 10, and then whatever else is going to be on my right side. But my technique is going to be looping through here. It's going to be slicing it basically. So I know basically that all of these are going to be on the left side. So if I take my preorder and I slice it from 1, okay, because I want to start at 5 here at the 1 index and go until you get to I, which is I is equal to 0, 1, 2, 3. But since this is exclusive, I have to do 4. If I want to include 3, I have to do 4. So it'll go to 4. I hope I didn't mess that up. I'm pretty sure, because it's usually exclusive and it's inclusive on the left side. It's exclusive for the n interval. That's how slicing works. I don't think I messed it up. I'm gonna see when I code it. So yeah, so you get this preorder, and once you have the preorder slice, you say, well, this is all going to be on my left side, so just set your current root, which is 8, set its left equal to this, right? And set the right, and set the right of the root. The right of the root will be whatever comes after that, which will be preorder, I guess, you're right, I, so it'll be everything I, so it'll be 4 to this, so it'll include this one. So you're setting that to the right, and I'm setting this to the left side. And that's the basic process. So each time I'm going to do that, and for my tree, it'll set, so how my recursion will work is it will set this this will be the first root, and I'll set this to be its left subtree, and this to be its right subtree. Then when I iterate, I recursively call, so I'm going to call it for the new preorder that's been sliced here for the left. So I'm going to go left, and then this will be my new root, the 5, and then that 5 will assign its left to be 1 and its right to be 7 by slicing, and then it will go to the 1, and when it goes to the 1, it will not have any other values in it, so it will, I kind of want to return, I think. Yeah, so when I go to the 1, I guess the 1 could continue going. It could do the left and do the right, but they're going to be empty, so that should be okay though. And then I'll just return, so my base case will probably be like if not preorder, return none. I mean, these are none, so you have none for your left, you have none for your right. Okay, and then it recurses back up, and then 7, it'll set none for its right, and none for its left, and so on. Oh man, that was really bad. Okay, anyway, I'm gonna try to do this. Oh, okay, so if I go to here and I do it, so I already wrote out some of this, so this is my base case. If it's not preorder, I'm going to return none, so I will just, that's going to be the end, and then, like I said, for each subtree, I want to take the root to be the first element in my preorder. The reason for this is, again, I can show my first slice. So my first root, so my preorder is, I'm going to write it out here, this might make more sense. Preorder equals this initially. So my 0th element will be the 8. So root then equal to 8. So I said root equal to, and I need to make sure it's a tree node and do preorder 0. Because I need to construct a tree node, because preorder just contains the values. So I construct the root. Yeah, sorry, because preorder is just a list. So then I'm going to say I equals to 1, and I'll say while I is less than, I never want to go above the length of the preorder, and also, and I don't want to, I want to stop once the root.val preorder I. So once the value becomes larger than the root.val, that means we're going to start the right subtree. So until that happens though, I'm going to keep incrementing I, increment I, and then I have to set the root.left equal to, I think I need self in here from wait, do I? I'm going to see. I'm not good enough to know if I need it or not. Preorder, and then what did I say? I said I to, no, 1 to I. Slice that, and then root.right, right equals self.bsc from preorder, and then this one will be just I, everything that's after I, and then I'm pretty sure I'm going to return the root. Now to really do this, let's think about what this is going to do. So my first root is 8, and when it goes down there into this while loop, I starts out as 1. I starts out as 1, and root.val is equal to 8, and preorder 1 is equal to 5. So it's going to increment it. So I will be equal to 2, and you're going to see I will be equal to 3, and then I think when I is equal to 4, you know, our root.val is still equal to 8, but preorder 4 is equal to 10. So yeah, it'll stop, and then it'll set the root.left of this root will be equal to, it'll call the BSC from preorder, and it'll set it equal to a preorder will become equal to Alright, it's taking me too long to do this. Preorder be equal to what was it, 517? Yeah, 517, and then we're saying the root dot right equal to preorder, which will be equal to 10 and 12, which makes sense, right? So you're saying the left subtree is contain all the values that are less than it, right subtree will contain all the values that are greater than it. So ooh. Oh, what? Did I? Oh. I think I said it, but I think I didn't do it. Yeah, you're supposed to continue as long as preorder is less than this. Okay, now submit. Alright, cool. So that was actually not that good, but this is also like, yeah, this didn't go very well. Oh well.